So in this video, we're going to look at 11.6, which looks at the difference between the practical significance of a hypothesis test and the statistical significance of a hypothesis test. Sometimes when we do these hypothesis tests, you'll see that there is a significant difference between, let's say, the p-value and that alpha value, that significance level. And you'll say, okay, there's enough of a difference, and let's say p is less than alpha, and there's a huge difference between them, so it's a significant difference, and we can see that this thing is statistically significant. We're definitely going to reject that null hypothesis. But sometimes p and alpha may be really close together. In the same way, the test statistic and the critical value might actually end up landing really close together. So even though you may end up rejecting or failing to reject that null hypothesis, it may have only just been a rejection, okay? Because the values may actually be really, really close together. So it may not be that statistically significant. But on the other hand, there may be a big difference between the values. Like that, you may have a really, really small p compared to alpha. And so there is a statistical significance, and we would definitely reject that null hypothesis with certainty. And there is a huge statistical significance there. But we also have to look at the practical significance of a hypothesis test. So let's say, we'll do an example to show the difference between the two. Let's say that you have bags of sugar that are 10-pound bags. So we have 10-pound bags of sugar. Okay. So you're saying that the mean amount that they are filled is 10 pounds. So you're saying that the mean is 10 pounds. But you take a sample of this population of bags of sugar, and the average amount in the sample is 10.01 pounds. So the sample mean is 10.01, okay? But the population mean, you think, is 10 pounds. And you take a sample, when you've taken this, you've taken a sample of 2,000 bags, okay? And let's say that they also had a standard deviation of 0.1, okay? Just throw that standard deviation in there. If we test this, okay, we want to see if the bags are actually filled to 10 pounds or not, okay? Is 10.01 pounds just too far away from that mean of 10 pounds? And can we no longer consider 10 pounds to be the actual mean, okay? So let's say you want to have H0 is that the mean is actually 10 pounds. But the alternative hypothesis suggests that the mean isn't 10 pounds, okay? Now, you can go ahead and test this, and it works out because you've got that sample standard deviation. You're going to be doing a t-test, so you're going to have a t-value for your test statistic. And to work that out, you do that sample mean minus the population mean divided by, it's going to be the standard deviation over the square root of the sample size. Okay, remember that back from when we did these test statistics back in it was 11.2b, I think. Okay, and that gave you 4.472. Okay, and we're going to test this at a significance level of 0.05. So 5% of the time we want to reject our null hypothesis. Okay, the question is, are we going to reject or fail to reject that null hypothesis? Well, you can go ahead and do this with a critical value, etc. But what we're actually going to do is to do the t-test just to make it easy. And for this particular example, the t-test gives us that p is going to be a really, really small number. Okay, that's a really small number, okay? When you do this, okay, and you find that p-value, you always compare it to alpha. Or if you do it the long way, you're going to compare this test statistic to the critical value. Okay, so you could go ahead and work out the critical value here. You've got a two-sided hypothesis, and you've got alpha is 0.05, so you're going to split on two tails, 0.05 on between the two tails, so you're going to have 0.025 on each tail, and you can go ahead and find out the critical value. So you could do it that way, or just do it the quick way with this p-value. Okay. Now, if we look at the difference between the p-value and the alpha value, p is definitely less than alpha by a very long way. Okay? So this test, you're going to reject the null hypothesis, but this test is definitely statistically significant. Okay? Because look at the difference between these two values. Okay? P is much less than alpha, so we definitely reject that null hypothesis. There is no doubt about it. The values aren't in any way close together. Okay? So this test is statistically significant. Okay? In the same way, if we would have done this test and found that P was much greater than alpha, okay, then again, you can say that it's statistically significant, okay? You would just fail to reject the null hypothesis in that case. But as long as you've got enough of a difference between the P and the alpha, or you've got enough of a difference between the test statistic and the critical value that you can 100% say, yes, this is the right decision in this case, then you can go ahead and say it's statistically significant. But let's go back to the initial problem, okay? We had these 10-pound bags of sugar being filled, okay? When we took that sample, the sample mean was 10.01 pounds. Practically, the difference between 10 pounds and 10.01 pounds is basically nothing, okay? There is hardly any difference practically between 10 pounds and 10.01 pounds. So this test is not practically significant. Okay, even though statistically we saw this massive difference, okay, so that we could definitely determine that we're going to reject that null hypothesis, okay, that null hypothesis that we're actually looking at here suggests that the mean is no longer 10 pounds. Well, that sample that you just got only had a mean of 10.01. That's hardly any difference, okay? So even though this test is statistically significant, it is not practically significant. So whenever you conduct these hypothesis tests, it's great that you get these statistics out, and it's a great way of computing and testing stuff. But you always have to go back to the initial problem and remember what you are trying to prove, okay, in terms of the initial problem. Because you can come out with this great statistical evidence, but if practically it doesn't mean much, then there's no point in testing, okay? So always remember that when you do this. So this test is statistically significant, but it is not practically significant. There's not enough of a difference between the sample mean and the population mean for us to really worry about it. Okay. Now, let's do a quick example. Okay, this comes from the Hawks homework. So they'll always do these in 3 steps, and they'll ask you a couple of questions afterwards. It says here that the director of the IRS has been flooded with complaints that people must wait more than 60 minutes before seeing a representative. To determine the validity of these complaints, the IRS randomly selects 350 people, so you've got a sample size of 350, across the country, and records the times which they must wait before seeing an IRS representative. The average waiting time for the sample is 62 minutes with a standard deviation of 5 minutes. Okay, so we know that we're dealing with means here. Okay, the population mean was 60 minutes, but they took a sample and the sample mean was 62 minutes with a standard deviation of 5 minutes. You have a sample standard deviation. What test does that signify? Well, we know that we're dealing with means and we've got a sample standard deviation. It's going to be a t-test. Okay. Is there overwhelming evidence to support the claim that the wait time to see an IRS representative is more than 60 minutes at a 0.1 significance level? Okay. So first things first, what I'm going to do is actually write down what we're proving. So our null hypothesis here is that the mean is actually equal to 60 minutes. And the alternative hypothesis, which they are suggesting, is that the mean is in fact more than 60 minutes. Okay, because they took the sample mean was 62. They want to look at if in fact that mean is greater than 60. Okay. So the first thing that they ask you for is the test statistic. Now, as I said, you have a sample standard deviation. You know it's going to be a t-test. Okay, you're dealing with means and you have a sample standard deviation that indicates t-test. So you can go ahead and calculate t, okay, which is equal to the sample mean, which was 62, minus the population mean, divided by the sample standard deviation over the square root of the sample size. Okay, so if you go ahead and do that, you should end up with 7.483. Okay. So that is your test statistic. Now you can go ahead and find the critical value. Okay, here they're doing this at the 0.1 significance level. So if you were to go ahead and draw this out, it's a right-tailed test with a 0.1 significance level. So you would have 0.1 as your area under the curve to the right. Okay, you know that your critical value must be on the right of this curve because you've got a right-tailed test, which gives you an area here of 0.9. You can go ahead and find Z1 by doing inverse norm with the area to the left, which is 0.9, mean of 0, standard deviation of 1. So you can go ahead and find that critical value and then see whether this test statistic is actually going to fall in this danger zone or not. Okay, so that's one way of doing it. Or we could do the t-test on the calculator. When you go ahead and run the t-test on this, you get a p-value. In this case, p is 2.975 times 10 to the negative 13. That is tiny, okay? It's this thing, but it's going to be 0.13 zeros and then 2975. That's a really, really, really small value compared to our significance level of 0.1. So without a shadow of a doubt, p is less than alpha. So we know statistically it's significant and we're going to reject that null hypothesis. So this thing is statistically significant. However, is it practically significant? Well, let's look at what the mean times were. The population mean was 60 minutes and the sample mean was 62. So that was our population mean and our sample mean was 62. Is that difference of 2 minutes really practically significant? I mean, if you wait 60 minutes or if you wait 62 minutes, is that really a significant difference? No, it's not. Okay, so although this test is statistically significant because we have a big difference between p and alpha, and p is most definitely less than alpha, although it's statistically significant, it is not practically significant because practically the difference between the sample mean and the population mean is not enough to really warrant a test like this. Okay, so even though it's statistically significant, it is not practically significant. We do not have enough of a difference between the sample mean and the population mean to make this thing practically significant. Okay, all of the problems are like this. They will ask you for a test statistic. They will ask you whether you're going to reject or fail to reject the null hypothesis, like we have done in 11.2 and in 11.4 with proportions. And then they will say to you, okay, is this test practically significant or statistically significant? Both, neither, you have to pick. Okay, so that's how the homework goes. If you have any questions about this, please let me know and I will see you in the next video.